Hi, today we're going to go back and discuss a little bit more about um, where y varies directly as x. Remember, we had that as a fraction. And we set it up as a proportion when we were trying to find the missing number for an ordered pair so that we could then find the slope given two ordered pairs. So what you need to know about this is that once you find the slope, then what we're going to do is write an equation based on that. So when we have the linear f of x equals 20x and we have the direct variation, what you need to know about this is that it goes through the origin. The b is 0. So you know this y equal mx plus b, okay, the slope-intercept form. This is your slope and this is your y-intercept. Now, we haven't seen the K, the constant of variation, in a long time on a test, but we do see the slope. So in this particular one, when you go up 20 over 1, that's actually 20 cents because it's 20 cents per cookie. So the cost of 20 cents is a function of the number of cookies. So cost varies directly with the number of cookies. All right, let's take a look. So this is a direct variation because it goes through the origin. Unlike example 2, come on. Unlike example 2, where you have a linear equation of y is equal to 75x plus 50. This is not direct variation. It does not go through the origin. It goes through the y-axis at 50. So the slope is 75 because it's the number in front of x. So the number of pages read is a function of the number of days passed. So it is a function, but it's not a direct variation. So like if we were trying to figure out the slope and y-intercept, it looks like it starts here at 50. So it goes up to, let's go see where it crosses through again. So it goes up to 200, so that's 150 over 2, which is 75, so 75x, but it starts at 50. So again, this is not a direct variation. All right, let's look at the back side. So what we're going to do, it's not that difficult. I mean, I think it sounds difficult just because we have some new vocabulary, but with the vocabulary, you're going to see that it's really not all that bad. So I'm going to just jump right into problem 1. Y varies directly as x when y is 50. So 50 divided by 5/9. Now you're probably looking at that going, oh my gosh, you have plugged that directly into your calculator. Now one thing is, make sure you do the control divide so that you get that horizontal bar. If you don't want to use the calculator, then this is going to be 50 divided by 5/9. Do you remember that phrase? Keep, change, flip, KCF. Okay, so we're going to keep the 50. We're going to change division to multiplication, and we're going to flip 5/9 to make it 9/5. So this 50 is like 50 over 1. So 5 and 50 are divisible by 5. So 5 divided by 5 is 1. 50 divided by 5 is 10. So 10 times 9 is 90. That's your slope right there. So these are direct variation equations. So your equation would just be y equals 90x. That's it. It's not that difficult. Okay, let's look at problem 2. Y varies and x is 14 when y is 44. So it's 44 because that's your y. Remember, it's y over x divided by 14. Well, if I divide each of those by 2, that gives me 22/7. And it says over here I can write it as a fraction. So it's just 22 over 7x. Number 3. The distance traveled varies directly with time passed. writing equation if the distance, remember the distance traveled varies greatly, so the distance is 250 and the time passed is 40. And remember, it's still y divided by x, and we can write this as a decimal. So 25 divided by 4 is 6 1/4, so 6.25x. Not that bad. And let's take a look at number 4. It looks like it's the last one. The height that a ball bounces varies directly. So right here, I'm going to, because that's going to be my numerator. So we're going to go find the height that a ball bounces. A certain ball bounces, so that's going to be my y. And then the other one will be my 80. So it's y over x, so 50 over 80. The zeros drop, so it'll be 5/8 x